A piecewise function is a combination of one or more functions put together on the same graph. Their x values are restricted so that each graph is just a piece. So up top here you see how the equations are going to be written. I have two separate functions, x plus 2 and the quantity of x minus 1 squared. Each one has its own x values. For the top one, it's x is less than 1. And for the bottom, it's x is greater than or equal to 1. So they are two different pieces, which is why it's called a piecewise function. Below to the left and right, you have two examples of what a piecewise function is going to be looking like. On the left, I have a horizontal line that ends at -1 and it continues off into the negative infinity direction. And then what I have starting at -1, -2, this is a quadratic function, which we will get to later in this course, and that continues on into the x of the positive direction. On the right side, I have something that is similar. I have another quadratic function that stops, and then I have a point at y equals 6, and then I have another linear function here between two restricted points. So this is what we're going to be doing with our piecewise functions. We're going to be seeing their equations, and we are also going to be graphing them. Before we get to the graphing, we are going to evaluate the functions for values. So here I have three different equations, all with their own restrictions as far as their x values go. And in 1, 2, and 3, I have x values that I want to plug into the function. So what I need to determine is where does my x value fit into my function, and then once I figure that out, I can determine its value. In number 1, I have f of 10, which means x is equivalent to 10. That's all that is saying. So if I go up here, I need to figure out which one of these three is going to give me a true statement. If I look at the first one, 10 is less than or equal to 1, I know is a false statement. If I look at the second one, 1 is less than 10, which is less than 3, that is also a false statement. So the last one hopefully will do it for me. It would tell me that 10 is greater than or equal to 3, which we know to be true. So I'm going to take my 10 and I'm going to plug it into only this last equation. So I'm going to use 6 subtract 2x. To find the value for our function, I'm just going to replace the x variable with the 10 that it has asked me to. So I'm going to have 6 subtract 2 times 10. I can multiply the -2 and 10 to give me a -20. So 6 minus 20 will give me a -14. So our value here is -14. Number 2, I'm going to do the same way. I'm going to plug my 2 in until I determine where my true value comes from. So if I start at the top and I put in my 2 for x, my 2 is less than or equal to 1. That's going to be false because 1 is bigger than 2. So if I look at my second equation, I have 1 is less than 2, which is less than 3. This is true because 1 is less than 2 and 2 is less than 3. So my value is going to come from the function 3. There are no x values, so my answer, my y, is 3. Now my last one here, I have f of 0, so my x is going to be equivalent to 0, and I'm going to plug in. So if I start at the top again, 0 is less than or equal to 1. I start out with a true statement. So I'm going to be using this very first equation, which is -2 times the absolute value of x plus 1. I can plug in the 0 for my x. So I have -2 times the absolute value of 0 plus 1. We're going to use our order of operation rules. So I'm going to do 0 plus 1 since that's inside of my absolute value, and that's going to give me 1. The absolute value of 1 is 1, so -2 times 1 will give me a value of -2. So our value here will be -2.